let's have a look at arithmetic sequence. Now, before we dive into the question, I would like to just to draw your attention to a few things. If you open your table, your maths table to page, I think it is, let's see, oops, that's not what I wanted to do. Page 22. Oh, hold on. Yeah, that's the page. So if you look at that page, when you have arithmetic sequence, arithmetic sequence is about two aspects. It's about Tn, and Tn means the term. So let's say the first term, the second, the tenth. That's what this formula refers to. And then it's about the sum, meaning we add a specific number of terms. So that's the first thing to know. It's about those two things. And the way your question will be structured, that first parts will ask about the term, and then the second parts will be asking about the sum. Okay, second thing, how do we know that we are having a sequence and series question? Because sometimes it's not easy to identify it. So what are the givens? If I see a table like that, that could indicate sequence and series, okay? And of course, paper one. But then there are as well words. Like here, we can see that word pattern. If you see a word pattern, that indicates sequence and series. But then let's just have a look at that question. Let's say that you are in the exam and you are looking at this question and you are not sure what is it about. You are saying the word pattern, okay. And then in that second part, you see SN. So that confirms, okay, it is sequence and series. Right, let's dive into our question. So Ellie takes up running. In the first week, she runs 6 kilometers. Each week after this, she runs 1.5 kilometers more than the previous week. So how does it work? 6 kilometers, and then next one, additional 1.5. So what do? We add. And that's the idea about arithmetic sequence, that every time we add the same value. So every time I'm going to be adding 1.5. So we have to complete the table to show distance Ellie runs each week for the first 6 weeks. So that's what we do. We add up. So 7.5 plus 1.5, that will be 9 plus 1.5, 10.5. And even for this simple calculation, for every calculation, I will encourage you in your exam to always use calculator. You don't want to make a mistake in simple calculation, and that sometimes it happens. Okay, and then the second part. If Ellie continue with this pattern, what pattern? Every time increasing her run by 1.5. Find the distance she would run in week 100. So one thing that we have to understand here when it comes to sequence. So when I'm looking at that number 6, so that number 6, that means that that is a value of first term. So one thing is about the value, but second thing as well, it means that this is first term. It stands as first. So the number, if I'm looking, let's say, at number 10.5, so on one side, that means the value of the term is 10.5. And on the other hand, it as well means that it's the fourth in that particular sequence. Okay. So we have to find the distance she ran. So that's my Tn, those values here, in week 100. So how do we do that? Well, we have a formula in our table for that. So we go to our table, we find the formula, and we write it down. Make sure you get to that I'm thinking about word. Make sure you always write down the formula, okay? So let's fill in the blanks. So T, and we are saying which term am I looking for? This is the 6th week. I'm looking for the 100th week, for the 100th term. That's basically what it means. That N here represent which term is it. So this is the 100th term. A is the value of the first term. So that's my 6 plus N again means the same thing that here. Always remember in your formulas, letters always represent the same number, minus 1. And D is the common difference, meaning what am I adding every time? So in this case, 1.5. And we put that in the calculator, we press equal, and we find out that in week 100, if she continues, she will run 154.5 kilometers. Okay, so that's what we find out, that's what she will run in week 100. Now, if you pause and think for a moment, that's loads of kilometers to run in a week. Okay, and that's the reason why we have that next question. Explain why Ellie cannot continue this pattern indefinitely. Well, even at week 100, if we are saying for somebody to run 154 kilometers a week, that I don't know whether it is even physically possible. Probably, maybe it is. I don't know. But that is a lot of kilometers. So if every time she's increasing, at some point she won't sleep, she won't eat, she will only run. So that's the reason why this pattern cannot continue, because it will get to too big distance. We can only increase it so far, and at some point we just have to stop. Okay, let's have a look at then the next part. So next part, Sn is the total distance in kilometers run by Ellie after n weeks, where n belong to n. Now, when we have in a lot of letters, sometimes can be confusing. So let's change that letter to some numbers. So I don't know, let's make it up so that we can understand it better. So let's say, I don't know, 50 is the total distance in kilometers run by Ellie after, I don't know, 8 weeks, where 8 belong to n. So that makes sense. We understand that this is how much in total she ran by a specific number of weeks. Now, I absolutely made those numbers up, so I don't know how much she ran in 8 weeks. So what do we need to do? We have to write that Sn in terms of n. So Sn, my Sn formula from the table, we take the formula, we write it down from the table. The reason why I'm telling you to, that's the one. So the reason why I'm telling you to write down the formulas, because you are getting your marks very often for writing appropriate formula. In terms of n, when they are telling you in terms of, that means that whatever follows, your answer have to include that. So my answer here at the end will have n. Okay, so let's see. So Sn equal, n remains n, that's what they want in the answer. So n over 2, bracket, 2 multiplied by a, what is a, the first term, and what was the first term? How much she ran? 6. So that's multiplied by 6 plus n again minus 1. And d is that common difference, meaning how much are we adding every time? That was 1.5. And here now we are saying, well, what can we do here? Well, we can multiply 2 by 6, and then we can multiply the bracket 1.5 by minus 1 and 1.5 by n. So let's write it down. N over 2, copy, paste, 2 multiplied by 6, that is 12, plus 1.5 multiplied by n is just 1.5 multiplied by n, and 1.5 by minus 1 will be minus 1.5. Now, the only other thing we can do here is that this 12 and minus 1.5, we can get them together as one number, isn't it? So my Sn will equal n over 2, 12 minus 1.5, that will be 10.5. Sorry, I had to think for a moment, plus 1.5n. So that it is. We now have a formula for total distance at any week. If I want to know how much altogether she ran in week 7, I put 7 here, and I put 7 here, and I get that. Or how much kilometers did she run in week 100? All together, not in that particular week, but all together from the beginning, week 1, week 2, week 3, week 4. That's what it is. Okay, let's have a look at next part. Using your answer to part B4, so that's my answer. Otherwise, find the total distance run by Ellie in kilometers after 10 weeks if she continues the pattern. That is, find SN. So I'm looking for S10. So total of what she run together in week 1 and then in week 2 and week 3 and so on. So my N here becomes 10 divided by 2, bracket 10.5 plus 1.5, and that multiply again by 10 here. And all we do, we put that in the calculator, press equal, and we have that what she run together from the beginning in week 10, 127.5 kilometers.